And now they want us to find an expression for the total surface area of the solid. So before we dive into all the formulas, are you able to identify how many flat surfaces are there from the diagram? How many flat surfaces? 2, right? Top and bottom. You can find the volume, the area for the top circle very easily. It is simply pi r squared. And the other flat surface, this is known as a ring, R-I-N-G, because there's a hollow in the middle. To find the area of that ring, we take the area of the big circle, we minus away the area of this small circle in the middle. And we get the area of that ring. So then after that, we need to add the area of the ring with that circle at the top. Do you see there's a duplicate of work? Right? To find the total flat surface area, if you are trying to find the area of the ring separately and the area of the circle separately, we are doing duplicate work. Because if we call this area, let's call it X. Then to find the area of the ring at the bottom, we need the area of the big circle. Let's call it Y. Area of ring will be Y minus X. Make sense? Y minus X. That's the area of the ring. And then after that, because we want the total surface area, total flat areas will be area of the ring, Y minus X, plus the circle on the top, X, which in total gives us 1. So the total flat surface area is simply area of big circle. Don't care about ring or the small circle on top, hole at the bottom, doesn't matter. How you visualize this, How you visualize this is that you can push this flat surface off, push it out, and then you get a complete circle. Okay, so that is the total flat surface area. Don't need to go through the trouble of finding area of the ring. Just pi times radius, in this case 3r squared, for the total flat surface. So that's how you reduce the amount of work that you have to do. A similar idea over here is when you were in primary school. So, for example, when you ask to find total perimeter of such a shape, where you have these are all right angles. Let's say this is 5 and this is 8, and then they tell you that this is 6. This is 2. Find the total perimeter of this shape. How will you do it? Will you actually 5 minus 3 minus 2 to get total distance here, 3, 8 minus 6 to get a distance of 2, and then add everything up? Will you do that? Or will you, in your mind, push the 6 up, push the 2 across? Oh, then it's just 5 plus 5 plus 8 plus 8. What will you do? Okay. Regardless, I want you to learn the easier way of doing it, which is still mathematically correct. In this case, just push up, push, you get a rectangle. In this case, push it down, you get a flat circle. Okay, next is our curved surface area. You can see that there are 2 curved surface areas over here. First is from the cylinder, that label. You know, I like to call this like a label. We have a cylinder and a label around it. That is the curved surface area, which you can cut and peel open to become a rectangle. This rectangle has dimensions. This over here is our height of the rectangle. And when you peel it open, the length of that rectangle is the circumference of the cylinder. Okay, you must be able to visualize that. You cannot go and take a piece of paper and wrap it around. Okay, wrap. See the excess over here? Cut off the excess part. Then when you unwrap it, you will get the same height as the bottle. That is your breadth or the height of your rectangle. The circumference is actually your length. So this curved surface area, as described from that paper, we've got our circumference multiplied by the height. Okay, so curved surface You know what? I'll just put everything into one long working. Total area. Okay, we've got a flat first. Flat simple. Pi 3r squared. So this is all the flat surfaces already. Then plus, I was talking about the curved surface area for the cylinder. So the perimeter, 2 pi r. 2 pi r, which corresponds to the length of the rectangle, multiplied by its height, in this case 2r. So this is our curve for cylinder. Curve area for the cylinder. And finally, we have the curved surface area for the hemisphere. We have a formula for curved surface area for a sphere, a total sphere. That is given by 4 pi r squared, everything. Very tired. You need to go and wash your face. So 4 pi r squared is the total surface area for the whole sphere. We need 1/2 of it. So plus half of the total surface area of a sphere, which is given by 4 pi r. Radius for the sphere is 3r. So 3r squared. So here we have an expression for everything. Expand and simplify. So we get 9 pi r squared plus, here we get 4 pi r squared, and finally 2 times 9, which is 18 pi r squared. Total 27 plus 4, 31 pi r squared. So we can see that the total area depends on the value of r only for such a figure. As your r changes, the total area will also change. Anybody needs more time? Anyone finish? Oh, okay, put it in units. Square units. Sitting finished? Okay, for question 7, anybody doesn't know how to do? Don't know, raise up your hand. Then I won't call you. Okay, Jolie, later you help us with part A. Okay. Xintian, help us with part B, part 1. Shini, part B, part 2. Then Aloysius, part B, part 3. No, sorry, Omera. Part B, part 3. I missed you. I'm going this way, by the way. Domain finished? Okay, Jolie, ready? So question 7. We've got a hot water tank made by joining hemisphere radius 30 cm to open cylinder, radius 30 cm, height 70 cm. So it's a hot water tank. And in your O levels, in your end of year exams, the surface area of a sphere, the volume of the sphere will be given to you. But during the test, it is not given to you. So you still need to memorize it. So first, Jolie, calculate the total surface area, including the base of the outside of the tank. Okay, so how do we go about doing this? Did you do everything in one step? Everything in one step. Okay, Ken. So total area. Okay, how did you start off? 4 pi times 30 square. Can you explain what this is for? So of the hemisphere. Okay, so the half over here is for hemi. So this portion is for total area of sphere. Okay, good. So that's the top part. She went from top, and let's see which one she will do next. Yes, so Jolie. 2 pi 30 70. Can you explain what this is for? Very good. Curved surface area of the cylinder. Can you describe what is 2 pi times 30 is for first? Two pi times 30. Not the 70. 2 pi times 30 first. 30 is the radius. So what we have over here is 2 pi r. That's the formula for circumference. Okay, so we can call it a perimeter because I want you to remember a cylinder is like a special type of prism. So call this the perimeter circumference also can. Okay, then the 70 will be our perpendicular height. Okay, next one final area. Pi 30 square. So this will be our base. Base. Okay, so there are 3 parts to them. And what is your answer? This is 3 SF, is it? Can I have the 5 SF? Don't have, calculate. That you always must calculate in case it is used in the next part. So for example, if the next part says 1 square meter of paint costs how much, calculate the amount, the cost required to paint everything. Then Jolie, you have to calculate everything again because you cannot use the 3SF. Okay, so round off to become 21700 square centimeters. Okay, next, Xintian, the tank is full of water. Calculate the amount, the number of liters of water in the tank. So part B now. Let's do it at the side. Part B, volume. Okay, so what do you do? Well, we don't want to just start with numbers, huh? Give me an expression. Volume of water, is it? Or capacity, capacity. The keyword is capacity, right? So capacity. So we know that capacity has got to do with the volume. Yes, okay, so what do you do? Do you say 4/3 pi? 4/3 pi times 30 square. Okay, what is this for? Oh, the whole thing times half. Okay, so let's put a half in front. So half times 4/3 pi r square, is it? Okay, what is this for? Okay, so the half again refers to the hemisphere. And you're saying that 4 third pi r square is the volume of sphere, is it? Is it? Okay. So Xinyan, help me out over here. The 4 third, does it have any units? Or is it just a number? Just a number, okay, no units. How about the pi? Does it have any units? No units. What about the 30 over here? Does it have any units? Have, right? What are the units? cm. Okay, very good. What happens when you square a cm? What happens when you square cm? Come on, trust your instincts. What do you get when you square a cm? Very good, cm square, right? Okay, when you square the cm, you get square centimeters. Xinyan, look, capacity. What are we expecting for the units? What are we expecting? Cm cube, right? Not cm cube, right? Then your cm square only. What went wrong? Okay, so this is a way to very quickly identify something is wrong in the working already. So what do you think happened? Why would you think that it is 4 third pi r square? Is it 4 third pi r square? Yes, no, or don't know? Don't think so, then check. I thought it's written over here. What does it say? Cube. Formula given must be able to apply properly. Must be able to apply accurately. Okay. So here, if you go through the same process again, you'll realize that okay, now volume has cubic centimeters as its unit. And then now your formula will make sense. Can you see that in here? Great. So now we've got the volume of the hemisphere, but that is not all. What else do we have? Okay, very good. So what is the volume of a cylinder? Pi times 30. No. Times 70. Okay. Tell us what is pi times 30 square? What is this pi times 30 square for? Why you keep looking at Shini? It's her work or your work? Base. Missing one keyword. Base area. Okay. Then this will be our perpendicular height. Okay, very good. So now we've got a capacity. The units over here will be in cubic centimeters. Okay. By the way, just to show you, same argument. 30 over here, when you square it, you get square centimeters. Then this is 70 in cm. When you multiply them, you will get cubic centimeters. You can add like terms together. Just like you add x and 2x, you get 3x. You cannot take x plus y and get like an xy or something like that. Different. So here we've got cubic centimeters. This is also in cubic centimeters. So we are able to add them up. They are kind of like terms. We are all finding volume, volume, volume. Okay, so you cannot be like finding volume equals to area plus volume. Don't make sense. They're unlike terms. Okay, so Xin here, what do you get for the answer? Give me 5 SF. 254 46. Faster, we're waiting. What's the value? You answer or not? No answer, eh? Two five four four seven seven 70. This? Okay. React current. 254469. Okay, never mind. 3SF. So this is in cubic centimeters. Round this off to 254000 cubic centimeters. Okay, so currently I didn't calculate. So if you think there's anything wrong with it, please sound out, okay? So finally, they wanted in liters, yeah? Okay, so Xin Hian, please finish up. What is this in liters? .254 liters. Okay. So next one, Shini. Part 2. The water drains from the tank at 3 liters per second. Calculate the time in minutes and seconds to empty the tank. Oh. Part 2. What do you do? I don't want just numbers. Do you just give me numbers? I want a word or 2 words, 3 words. I want some words. Time taken. Okay, time taken. So what do you do? 254 divided by 3. And what did you get? 254 divided by 3. What do you get? Two over 3. Wait, what unit is this? Okay, seconds. Then? Okay, convert. 1 minute 24. 1 minute 24 seconds. Over your 2/3 second. One minute 24 seconds is only 84 seconds. Eh? Over your 2/3 second. Huh? Do you recognize that there's a missing 2/3 second? You don't? Okay, so 1 minute 24 seconds is only 84 seconds, right? Yes or no, Shini? But the total time is 84 and 2/3 seconds. Do you agree? So what happened to the 2/3 second? Cannot just ignore it, right? You have to round off. We got 2 minutes. No, don't have 2 minutes. 1 minute 25 seconds. So this is rounded off to become 1 minute 25 seconds. Cannot. Okay, now Omera, your turn. All the water from the tank runs in a bath which is just completely fused. This statement tells us that the volume of the hot water tank is equal to the volume of this tank. The bath is a prism, cross section is a trapezium. 0.4, 0.6 are the parallel sides. 3 meters is the depth. Calculate the length. Huh? Okay, volume bath. Wait. Equals to 2544770. Let me just verify. 2544770. 70 cubic centimeters. Okay, what do you do with that? It's not there. Cannot do it. Okay, look at what I just circled. All the water from the tank runs to the bath, which is just completely fused. So you know that the volume of this bath, is it this bath? Equals to 2544770, same volume, right? Okay, then I need an any expression for the volume of this prism? Surely this 254470 must have something to do with the 0.6, 0.4, 0.3. And the question wants us to find this part, length. Okay, so what do you think? If I tell you that the volume of this trapezoidal prism is 254470, can you give me an expression for the volume of that trapezoidal prism? Meaning, can you find out the volume? Okay, how to find that volume? Okay, good. This is equal to the base area of that prism, right? Which is what shape? Trapezium. How to find the area of that base? What is the formula for area of a trapezium? A plus B divided by 2 times square. Okay, correct. So what is your A and your B? 0.6 plus 0.4, then divided by 2, then you say times your perpendicular height, right? What is the perpendicular height? 0.3. Okay, then now that we have an expression for the base area, what do we do next? So it says that this is the base area of tank. Okay, what do we do next? Volume. Base area times. I mean, there's nothing to calculate. Times what? Huh? Yes, but although we are finding the length, we are trying to write an expression for the volume. Times what? Length. Okay, what is length over here? Do we know? We don't know. That is why we use algebra. What did I call the length over here? In the diagram, what did I call the length? L, yes, L. So by right, based on this, we should have number, unknown. I can solve, right? Okay, now I'm going to put you through the same exercise as Xintian. What is the units on the left-hand side? What are the units? Okay, cubic centimeters. What are the units for 0.6? Meters. Then how? This one in meters. Then what is 0.4? Meters. So meter plus meter. What about this 0.3? So meter, right? Meter plus meter, still meter. Divided by 2, still meter. Meter times meter. This will give us square meters. Then what is your unit for your length? Wow, that is very complicated. It is probably going to be meters, right? Then your meter square times meter, you're going to get cubic meter. Doesn't tally. So the answer will be wrong, even though the approach is correct. Okay, so what should we do? Change which one? To become? Correct. So what is your 0.6 in cm? Okay, so change it to 60. 0.4 becomes 40. 0.3 becomes 30. Now, what will the units be for your length? Automatically, it will become cm. Okay, so go and work it out, and you get an answer for the length in cm. State the length of the bath. Sorry, our laptop very lag today. Length of the bath. Okay, so this will be in cm. You can work it out yourself. I was afraid you would say you want to change the cubic centimeter to meter. You know why? Don't know. Aloysius, do you know why? How do you change cubic centimeter to cubic meter? That's my question actually. What? What are you talking about? Okay, now your job is to change this 254470 equals to how many cubic meters? Okay, how? Did you say divide? Aloysius, did you say divide? Yes, all right. Okay, divide by what? Divide by 100. Divide by 100 again. So divide by 100 two times, is it? So I mean divide by 100, divide by 100. So can I short form and divide by 100 square? Is that all? You think it's 100 cube? You think anybody else thinks the same as him? Divide by 100 cube? A few. Yes, you are supposed to divide by 100 cube. It is not complicated. You might be complicating things by yourself. Now look, guys, all look up, revision. You will be tested on this. If I change this to just cm, okay, remove everything. From cm to meter, what do? Divide by 100. From cm square to meter square, what do? Divide by 100 square. From cm cube to meter cube, what do? Divide by 100 cube. So, Aloysius, I'm not sure what was going through your mind when you were thinking about dividing by 100, dividing by 100 again. Although you were on the correct track, then after that, you were not sure whether you should divide by another 100. So that means you're not too sure already. Okay, but now it is just as simple as this. So if you want to go the other way around, from cubic meters, or rather from meters to cm, you times 100. If you want to go from meter square to cm square times 100 square. If you want to go from meter cube, cm cube times 100 cube. That's all. The same can be done for square meter to square kilometer. Cubic millimeter to cubic centimeter, all can be done. So this is all for our notes. We've got our textbook question next. Okay, let's go to our textbook question. Exercise 10.3, 7, 8, 13, 20. Question 7 first. Okay, so a soccer ball is a volume 5920 cubic centimeters. Find surface area. It's just working backwards to get a radius. So 4 pi r cube, that is our formula for the volume, equals to 5920. Very easily find the value for r. Okay, so here we've got a value of r correct to 5 SF. So notice that they do not leave it in 3 SF. It's 5 SF. Because we are going to be using this value again for finding the total surface area. In fact, I wouldn't even write 11.222. I will leave my radius as cube root 4440 over pi. That will be a better value to use. Then from there, simply substitute the value of the radius into 4 pi r squared. So 4 pi r squared, you get 1580 square centimeters to 3 SM. Anybody needs more time? Need time, raise your hand. Don't raise your hand and move on. Next. Question 8. Okay, these are similar to one of the questions we did in our notes. Hollow glass sphere, external diameter 9 cm. So when you are given diameter, quickly think about converting to radius, because all our formula in radius. We don't have, except for circumference of a circle, pi d. Everything else is in radius. So anytime I'm dealing with circle, right, important, find radius. So radius, simply 9 divided by 2, 4.5. The thickness is 2 cm. So I see that, oh, it's going to be a exterior sphere and a sphere in the center. That sphere in the center has a different radius. It will be 2.5 cm. Because 4.5 minus 2, I get 2.5 cm. So I can find the external surface area, I can find the volume. So external surface area, 254 to 3SF. So to find the volume of the glass, take the big volume minus the small volume. You got a formula for big volume, which is the same volume, same formula for small volume. Just get the radius correct, that's all. So as mentioned, internal radius 2.5 cm. So the volume of the glass is just 4 pi r cube minus another 4 pi r cube. Typically, students will just evaluate this first step, press calculator, or press everything. But the textbook is showing you that actually you can factorize. Because you got the same factor, 4 pi. Factorize it all. It becomes simply 4 pi times 4.5 cube. This is the radius, the cubic, minus the cube of the smaller radius. Okay, you can factorize it to do fewer entries in your calculator. But if you're very confident of your calculator skills, no problem. First step, go ahead, use your calculator already. So 3SF, 316 cubic centimeters. Next one is question 13. Anybody needs more time? No? Then next. So we've got a hemispherical clay bowl. Internal radius 7 cm, thickness 1 cm. Find the capacity. So capacity will be half of the volume of a sphere. Which sphere? Capacity means the amount of fluid you can put into this container. So we're talking about the volume of the internal hemisphere. So we should be using radius as 7. So half times of 4 pi r cube, 718. The volume of the clay used. By now you should be an expert already. Take the volume of the external hemisphere minus the volume of the internal hemisphere. It's just a subtraction. So because you already have the volume for part A, you just minus away 686 over 3 pi. It's the same. See, we do not use the 3SF anymore, use the most exact one variable over here. Okay, so if you had used your calculator from the first step straight away, half and 4 pi times calculator, right answer, and then you don't write your 5SF, you straight away write 3SF. If you use that 3SF value, which is 718, you put it over here, wrong. So if you know that 718, I cannot use 718, then you have to go and press calculator again to get a 5SF. So waste time. That's why make it a habit. Always write down the 5SF or the most exact value first, then run. Next one, part C, is to find total surface area of the bowl. So you can see that surface area for this bowl, we've got an outer curve, we've got an inner curve, and we've got a ring, R-I-N-G over here. Area of ring is simply big circle minus small circle, that's all. So it's a matter of getting the correct radius for all of them. Okay, the first portion, half times 4 pi r squared. This refers to the curved surface for the big hemisphere, the exterior curved surface. Another half 4 pi r squared. This will be curved surface of the inside of the hemisphere. This pi r squared minus pi r squared, this is the flat surface area, meaning the area of the ring. Final answer 757. Final question number 20. Anybody needs more time? Ling Huan finish? Finish. Matthias, you look very engrossed in something. You're looking at the next question already, is it? Why your face like turning red? Okay, rectangular box to pack 8 table tennis balls, each of diameter 4 cm as shown. Dimensions of the box so that internal surface area is the minimum. For it to be minimum, I need the top of the box to be touching the top of the ping pong box. I need the sides to be all touching. So if I want it to be the smallest, and I know that the diameter is 4 cm. So this is 4 cm. This is 4 cm. Total 8 cm. Okay, I know the height already. That's 8 cm. Similarly, 4 cm over here, another 4 cm, 8 cm. Likewise on the other side. So this is actually a cube. 8 cm, 8 cm, 8 cm. So part A, the dimension 8 cm by 8 cm by 8 cm. Okay, so this is how we write dimensions. Dimensions 8 cm by. So this multiply over there, yeah, looks like multiply, we call it by, by. 8 by 8 by 8 cm. It looks like we are actually multiplying all of them, and that would actually give us a volume up. So for cuboids, if we ask for, you go to IKEA, you want to buy a table. So they give you the dimensions. What is the length? What's the breadth? What's the height? If you multiply those 3 numbers, you get a volume of the cuboid that covers the entire table. So this is how we write our dimension. So next one, find the amount of space in the box, which is part A, not occupied by the table tennis ball. So we see very clearly that when you put it inside, there will be empty space. So the empty space must be volume of the box minus volume of the 8 ping pong ball. Volume of the box, simple. 8 times 8 times 8. Volume of the ping pong ball, so very simple lah. 8 times volume of 1 ball. 1 ball has a volume of 4/3 pi r cube. Radius is just 4 divided by 2. Okay, so yeah, so volume of the balls will be 8 times of 4/3 pi r cube. Can answer or space minus answer. Go for 4.